students, I'll explain about exo and endothermic reaction, though I have already explained you this in my very first class. So since it is in page number 67, so we're going to learn it once again. Okay. So let us see what is exothermic or endothermic reaction. Exo, evolution. Endo, absorption. So the reaction which proceeds with the reaction, exothermic reactions are those reactions which proceeds with evolution of heat energy, whereas endothermic reactions are those reactions which proceeds with absorption of heat energy. So exothermic reaction proceeds with evolution of heat energy. Endothermic reactions are those reactions which proceeds with absorption of heat energy. You can see the example here. A plus B gives you C, A plus B gives you C. But exothermic is represented by the symbol plus triangle and endo by the minus triangle. So this one is exothermic reaction and this one is endothermic reaction. Plus it means exo, minus it means endo. Now you have to remember some examples of it. You can see here in this reaction, this is combination. A plus B gives you product. It's combination as well as reversible, as well as catalytic oxidation reaction. But during this reaction, heat is being evolved. Plus triangle means heat is evolved, and heat evolved means it is exothermic reaction. Similarly, student, when these two react, we get this. This is also combination reaction, right? Because A plus B gives you product. But here is also plus triangle means heat is evolved, so it is also exothermic reaction. Whereas when coke, that is carbon, reacts with steam, when coke and steam reacts at 1000 degrees Celsius, you get the mixture of carbon monoxide and hydrogen. Take this C here, take this O here. If you take this O here, you get CO. Then once you take this O here, what is left here? H2, so which is here. So CO plus H2 you get, and the mixture of these two is called water gas. So do remember, water gas is a mixture of carbon monoxide and hydrogen gas. So if anyone asks you what is water gas, you will say that it is the mixture of carbon monoxide and hydrogen gas. Okay, so when you react carbon with steam at 1000 degrees Celsius, you get the mixture of carbon monoxide and hydrogen gas, that is water gas. And this is an endothermic reaction because minus heat means, minus triangle means minus heat, means endothermic reaction. So my objective question to you, when carbon reacts with steam, we get water gas. When carbon reacts with steam, we get water gas. What kind of reaction it is? Is it exothermic or endothermic reaction? So answer is endothermic reaction, students. Okay. Now here again nitrogen and oxygen is reacting to give you NO. It's a combination reaction. You are heating it, it is decomposition, but it is reversible, so it is thermal dissociation reaction. And in this reaction also heat is absorbed. Minus heat triangle means endothermic reaction. Whereas in this reaction plus heat means, plus triangle means it is endothermic. So if it is plus triangle, that is exothermic, minus triangle means endothermic reaction. So do remember the definition. Exothermic reactions are those reactions which proceed with evolution of heat energy, represented by plus triangle. Endothermic by the absorption of heat energy, represented by minus triangle. And some are exothermic, some are endothermic if the heat is mentioned out there. Okay, plus triangle means exo, minus triangle means endo. Remember a few examples and remember this one. When carbon reacts with steam, we get water gas. What kind of reaction it is? Exo or endo? It's endothermic. Fine. Now below this you will see decomposition reaction. No need to study this because we have already discussed about decomposition reaction in very much detail in my previous video. So no need to study about decomposition reaction from this page. Now students, if you go to the next page, you will see oxide. Okay. In oxide, again, you no need to learn preparation of oxide. I have cancelled it. No need to learn preparation of oxide. But do remember, when sulfur and oxygen reacts, we get sulfur dioxide. When zinc and oxygen react, we get zinc oxide. That means any compound from sulfur to iron, when reacts with water, or oxygen, we get oxide. Sulfur dioxide, zinc oxide, magnesium oxide, iron 3 tetraoxide, tri-iron tetraoxide. So all of them are oxide. But some oxides we even get by heating only. These are the compound. When you heat them, you get oxide like lead oxide, calcium oxide. Okay, so you can say that we can get oxide in the product side either by reacting the elements or compound with oxygen or with water or simply by heating. So we get oxide either by reacting the elements and compound with oxygen, water, or by simply heating. And now what we have to learn is the classification of oxide. And this is important, and I may give you an examination. Okay, this is very important, and I may give you an examination. Now see out here classification of oxide out here, students. There are usually four types of oxide. One is called acidic oxide, one is called basic oxide, one is called amphoteric oxide, and one is called neutral oxide. So there are four kinds of oxide: acidic, neutral, basic, and amphoteric, in which acidic and neutral comes under non-metallic oxide, whereas basic and amphoteric comes under metallic oxide. There are four types of oxide, students: acidic, basic, amphoteric, and neutral oxide. You can see out of these four oxide, acidic and neutral comes under non-metallic oxide. Okay, and basic and amphoteric comes under metallic oxide. But right now you remember, afterwards you'll forget. So remember this word, and a and naan. I think when you go to Siliguri to roam around, okay, you want to have naan, chapati. So what is the full form of that? Non-metallic oxide are usually acidic oxide and neutral oxide. And here we have, remember, MBA. MBA means Master in Business and Administration, but our meaning is different here. M means metallic oxides are basic oxide and amphoteric oxide. So remember NaN and MBA for this. So what you have to remember for these all is the examples. And one difference between, if I ask you the difference between acidic oxide and basic oxide, you will say like this: differentiate between acidic and basic oxide, 1 marks. So say acidic oxides are non-metallic oxide, whereas basic oxides are metallic oxide. Finished. That much. Acidic oxides are non-metallic oxide, basic oxides are metallic oxide. Remember that much, more than enough. Okay. Now what you have to remember is the examples. So example of acidic oxide are sulfur dioxide, nitrogen dioxide, carbon dioxide. So sulfur dioxide, nitrogen dioxide, carbon dioxide are the example of what, students? Acidic oxide. Remember the examples. Okay, you'll remember the examples. Example of basic oxide is potassium oxide, sodium oxide, and calcium oxide. Just remember the examples. And amphoteric oxide means those oxides which can act as both acidic and basic oxide. Amphoteric oxides are actually those oxides which can act as both acidic and basic oxide. Those who can act as both. Like when you say amphibian, they live in water and land. So here amphoteric means the one who can act as both acid and basic oxide. So the oxide which can act as both acidic and basic oxide is called amphoteric oxide. An example is zinc oxide, lead oxide, aluminum oxide. And neutral oxide means those oxide which neither act as acidic oxide nor act as basic oxide. Okay, and the example of neutral oxide is nitric oxide, carbon monoxide, and nitrous oxide are the example of neutral oxide, students. So do remember the examples. Okay, there are four types of oxide: acidic, basic, amphoteric, and neutral, and which comes under non-metallic oxide, which comes under basic metallic oxide. Remember. Then remember the example of acidic oxide, basic oxide, amphoteric, and neutral oxide. And do remember amphoteric oxides are those oxides which can act as both acidic and basic oxide. Examples are here. And neutral oxides are those which neither act as acidic nor act as basic oxide. Remember example: reaction with water not required, reaction with base not required. Okay, now we go to the next, and that is called miscellaneous oxide. And it is a different variety of oxide. Okay, miscellaneous oxide means different variety of oxide. Okay, beside acidic, basic, amphoteric, and neutral oxide, there are miscellaneous oxide. And miscellaneous oxide example is here, students: sodium peroxide. It is called sodium peroxide. It is called here, one of the example of miscellaneous oxide is Na2O2, and it is sodium peroxide. And another one is mixed oxide. Example Fe3O4 and Pb3O4. Remember examples only for miscellaneous oxide. And another one is lead dioxide. Lead dioxide. Okay, these three are the example of miscellaneous oxide. Just remember the examples. More than enough. Now we go to the amphoteric hydroxide. So again, you will remember only the example of amphoteric hydroxide. So amphoteric hydroxides are those oxides which can even react with acid or base. Ampo means it can react with both. So the hydroxide which can react with either acid or base both is called amphoteric hydroxide, and the example of those you remember as zinc hydroxide, lead hydroxide, and your aluminium hydroxide. These three is because of the valency of aluminium, these two is because of the valency of lead, and these two is because of the valency of zinc. So zinc hydroxide, lead hydroxide, and aluminum hydroxide are the examples of amphoteric hydroxide. So do remember, students, classification of oxide with their examples, and about miscellaneous and amphoteric hydroxide, again the examples. So by this we come to the end of the chapter now. So we'll be solving some objective questions from the back in our next class.